Okay, second page to review is kind of where we left off on page 1. We have to draw or figure out the ordered pairs for each of these. So 5 pi over 6 ends up over here in the second quadrant. Reference angle is pi over 6. So my ordered pair would be negative radical 3 over 2, positive 1/2. I want the cosine, so I want negative radical 3 over 2. Here I want the sine of pi over 3. Don't really need to draw that because that's in the first quadrant. I just need the ordered pair for it though. I need to know that for pi over 3 the ordered pair is 1/2 radical 3 over 2. So the sine is radical 3 over 2. And when I add those two things together, they're opposite of each other, I get 0. Alright, 6. I have to find the secant of 3 pi over 2. So 3 pi over 2 ends up right here. Ordered pair is 0, negative 1. The secant is the reciprocal of the x value. Well, the reciprocal of 0 is undefined. So right away I know that that value is going to be undefined, so I really don't need to finish. I just know that this whole thing is going to be undefined. If any part of this is undefined, your final answer has to be undefined, because if you're going to put that in your calculator, you would get an error message, and that's what we're looking at there. Alright, 7. Now this one, the cosine of pi over 6. Cosine of pi over 6 is the x value of pi over 6, which is radical 3 over 2. The secant is the reciprocal of that. So really, I know then the reciprocal of that is just 2 over radical 3. And I know if I take anything, so even if this was an angle you didn't know, if you're going to take the cosine of that angle times the secant of that angle, no matter what it is, because they're reciprocals of each other, you will always get 1. So that could have been the cosine of pi over 10 times the secant of pi over 10. I still would get 1. Okay, same thing with 8. You see that you have pi over 12. You don't know pi over 12, but it does say the sine squared of an angle plus the cosine squared of that same angle. If you take the sine squared plus the cosine squared of any given angle, you have to get 1. Okay, that's that Pythagorean identity you need to know. And this one has to do with squares again, but it's secant minus tangent. So if you forget what those are, think about the original sine squared plus cosine squared of any angle has to equal 1. If I want to get to secant squared or tangent squared, I'm going to have to divide by cosine squared. And if I did that, I'd get sine over cosine is tangent squared, plus cosine squared over cosine squared is 1, has to equal 1 over the cosine squared, which is secant squared. That's the trig identity that we need to work with that deals with tangents and secants. So if I start with this and I want to get tangent squared or secant squared minus the tangent squared, I just have to take this trig identity and subtract the tangent squared. So you kind of have to make sure that you think about, okay, how do I get to secant squared minus tangent squared? I'd have to take away the tangent squared, so that would have to equal 1. Now, don't think that it always equals 1, because sometimes we've had ones that equal 0, sometimes they equal negative 1, so make sure you take the time to think about that, what you get there. If the question was, what's the tangent squared minus the secant squared, then you'd have to subtract secant squared and subtract 1. That would be negative 1. Alright, and then this one. This one I see that, I don't know pi over 21. So anytime you don't know an angle and it's not one of the Pythagorean identities, draw the picture. So pi over 21 is over here somewhere. And 20 pi over 21 is over here somewhere, but it has the same reference angle. They both have a reference angle of pi over 21. So I'm going to take the x value of this angle, which is there, add it to the x value of this angle, which is there. They're going to have the same x values because they're the same triangles. And so if I take this x value and add its opposite, I know I'm going to get 0. Now, I also could have even had that be 22 pi over 1, because that still would have the same reference angle down here, and I still would know it's 0. So just anytime it's an angle you don't know, and it's not a Pythagorean identity, or it's squared, then you want to make sure that you go and draw that picture. Alright. Find the remaining trig functions. So again, draw a picture of this. Sine is positive, so if sine's positive, I know it's up in the first or second. That's the y value. And the secant, which deals with the cosine, is negative. So I know the angle's up here. So I draw in my triangle. Secant is, remember, r over x. So if it's negative 7, that means our value has to be positive. So r is 7, x would be negative 1. So if there's 7, that's negative 1. Now I have to find y. So to find y, I take negative 1 squared plus y squared equals 7 squared. 49 minus 1 would be 48. So perfect square that goes into 48 would be 16. So y is going to equal plus or minus, and in our case it's positive because it goes up, square root of 16, which is 4, times square root of 3. So 48 is 16 times 3. And that's where I came up with that, with 4 radical 3. And it's positive because I'm up in this quadrant. So once I know that's 4 radical 3, now I can find my values. Sine is the y value over the r value. Cosine is the x value, which is negative 1 over 7. And that I could have gotten from just knowing it's the reciprocal of secant. Tangent is y over x, negative 4 radical 3. Cosecant is reciprocal of the sine, so it's going to be 7 over 4 radical 3. And to rationalize that, I just have to multiply by radical 3 over itself. So I'm going to get 7 radical 3 over 4 times 3, because that's what I get when I multiply them together, which is 12. And then cotangent is the x value over the y value. And so again, I have to multiply by radical 3 over itself. So I'm going to get negative radical 3 over 4 times 3, which is 12. Okay, so I'll look for, when I grade these, I'll look for the picture that you're in the right quadrant, you label these correctly, then you found y correctly, and then once you have your 3 parts to the triangle, that you use those to find your answers. Remember, when you do this, your sine and cosine always have to be between negative 1 and 1. Alright, so that brings us to number 2. Number 2, when you go to try to draw the picture, you'd say, okay, the cotangent's negative. Well, that's negative in the second or the fourth, and the cosine is positive, so you'd think it would be in the fourth quadrant. But when you go to try to label this, if this is x over r, x would be 4 and r would be 3. Well, r can't be smaller than the x value. I mean, that's the hypotenuse to your triangle, so it has to be bigger than your 2 sides. And then when you look at this, you probably, hopefully, knew that right away. Cosine's 4/3, that's bigger than 1. Cosine can't be bigger than 1. So this one is impossible to do. There's no solution to it because you can't draw it. It can't happen. Okay, so that's just kind of making sure you realize that your cosine and sines always have to be a number less than 1, in between negative 1 and 1. Okay, so that's page 2.